Good morning, good afternoon, and good evening, GHA family and friends. We are back with another homework helper video, and today this is for 6th grade. Okay, so we're in module 4. This is lesson 8. Okay, so we're going to be doing the problem set. That's the homework. All right, so I'm going to read the directions and then I'm going to get us started. So tonight's homework is pretty short. It's only 6 questions. Okay, so I'm going to go over a couple of these. All right, so actually, I'm not going to go over these because I'll just be giving you the answers. So what I'm going to do is I'm going to give you an example of these said properties, okay? So the first one, it says, number 1, state the commutative property of addition using the variables A and B, okay? So if we were going to show the commutative property, excuse me, okay? So the commutative property of addition is going to look like this as an example, okay? So we all know that 3 plus 2 equals 5, okay? So with the commutative property of addition, what this means is no matter how you flip this, your add-ins, these are add-ins, okay? No matter how you flip them, you'll have the same result. So if that's true, then we know that 2 plus 3 also equals 5, okay? All right, so what they want you to do is use the commutative property to show variables, okay? So we're doing expressions, okay? All right, so that means expressions do not have equal signs, so you don't solve them, okay? And only when you solve them is when they tell you to evaluate that, okay? So evaluate is another word for solve. If you don't see solve or evaluate, you are not to find the answer, okay? So don't make extra work for yourself, all right? Okay, so I just did an example of commutative property. I'll do another one. So if we're going to use variables, let's say we used v plus h. Then the commutative property says that h plus v is going to be equal to the same thing, okay? So that's the commutative property. We just went over that quick. We've just been going over that for the past 3 days, and I think you guys got a good grip on that, so I'm going to move on. All right? So we also have the commutative property of multiplication, okay? So I'm going to write that up here. Commutative property of multiplication. Okay, so if we had a definition of the commutative property of multiplication, that also means that no matter what you are going to multiply, let's give the example 5 times 3. So we know that 5 times 3 is 15, correct? Okay, so with the commutative property of multiplication, multiplication is the cousin of addition. I always say that they're family, they're related, okay? You can find answers to addition problems quicker by multiplying, okay? And if you cannot multiply, you can break it back down to addition if that's easier for you. So that means that no matter how we flip these two numbers here, you'll still have the same result of 15. So if that's true, then 3 times 5 is also 15, okay? So if they were asking you to use variables, meaning those variables do not have value to them, you would do something like this. So we could say C plus, oh, I'm sorry, not plus, we're multiplying right now. C times F. So then, if that's true, then the commutative property of multiplication says that F times C also has the same answer. Okay? So, while you're answering these questions, they want you to use said variables that are going to be listed there. So this is the commutative property of multiplication. Next, they're asking you to state the additive property of 0, okay? So, the additive property of 0. Okay, so A definition for the additive property of 0 is that no matter what that number is or what that variable is, if you add 0 to it, you are going to have the same result, okay? So if we were going to give an example, we would say 10 plus nothing. You're still going to be with 10, okay? So no matter what number you have in this space, if you are adding 0 to it, you'll have the same result. So if this was 20 plus nothing, you'd be at 20, okay? So this is an easy example of the additive property of 0. So if they're asking you to use variables or letters in place of that, then you would set up something like this. You would say, let's pick a letter. They'll give you letters. I'm picking a letter because this is an example. So let's say Z for 0. So we're gonna add 0 to it. We still only have Z. Our amount for Z has not increased because 0 is nothing. We haven't added anything to it, okay? So that's a quick example of the additive property of 0. No matter what your number is here, if you're adding nothing, you will be where you started, okay? And then we have our last property, the multiplicative identity property of 1, okay? So it sounds long, it's very easy, and it's not complicated at all, okay? So multiplicative, let's sound that one out. Identity property of 1, okay? So now, we did addition, then we did multiplication, then we did addition again. Now we're back to multiplication, okay? So the multiplicative identity property of 1 sounds very, very difficult, but it's not. So if you want an example, here's how it works. So say we have the number 7 and we're gonna multiply by 1. We know that anything times 1 is itself. I say that at least 3 times a day in class every day. So anything times 1 is itself. That is the multiplicative identity property of 1. So no matter what this number is, if you're multiplying by 1, you'll have that same number. All right? So I always like to make a joke in my class. Strickland times 1 is Strickland. Okay? Anything you put here, if you're multiplying it by 1, you'll have the same thing. 1,000 times 1 equals 1,000. Okay? All right, so with this, if they were asking you to use variables, then you would make up something, let's say like P times 1 is going to equal P. Anything times 1 equals itself, okay? So we just went over all the 4 properties, okay? And you had examples of each, all right? And so then number 5 says that you're going to demonstrate the property listed in each column by filling in the 3rd column of the table, okay? So you're going to do commutative property of addition, commutative property of multiplication, the additive property of 0, and the multiplicative identity property of 1, okay? So you've had examples, so they're going to give you an example of it, and you're going to either answer it or show the commutative property, all right? And number 6 is, why is there no commutative property for subtraction or division? And it says show examples, okay? So some of you might know this just from doing the work, but the commutative property of addition works like this. 3 plus 4 equals 7, okay? So if it's commutative property, then that means that 4 plus 3 is also 7, okay? There's no commutative property of subtraction because you cannot flip these either way and get the same answer. As you move along, further along in middle school and high school, you'll learn something about negative integers, okay? So let's try to demonstrate the property of subtraction, okay? So let's say we did 4 minus 3, okay? And that equals 1. But 3 minus 4, we can't do. If we only have 3, we cannot take 4, okay? So keep that in mind. I just explained to you in words and with numbers why there is no commutative property of subtraction. So you're going to use this as your example, and you want to put this in words as to why there is no commutative property of subtraction. Okay? Have a good evening.